Hello, can you see the mobile number given in the chat box? Please someone say yes or no.
No, sir.
Yes, sir.
Sir, can you please write
Okay,
it?
sending it. So you check the chat box, you can see there. Okay, so please save the number and message me your problems on WhatsApp. I will answer your questions. So you can see my screen, right? So you can see the screen, right?
Yes, sir.
Please send your questions to that number.
Yes, sir.
Send me questions, otherwise. Uh,
Please rewrite the phone number on the screen.
yeah, sure.
Thank you, sir.
So this is the phone number. Please save it down quickly. So you send your questions here. Via WhatsApp. So send this number and WhatsApp me. So first question is, it's question number 1. First question is P equal to log x of xy, Q equal to log y of xy, then P plus Q equal to what? This is the question. So P plus Q equal to what? Can you see my screen, by the way? Someone please confirm. I am writing, is it
Yes,
up?
sir, it's visible.
Yes, sir.
And also this looks like not equal to what, this is actually equal to. Okay. So now P plus Q, this is equal to log x of xy plus log y of xy, and this is equal to log x of x plus log x of xy plus log y of, oh sorry, not xy, it is just y. So this is log y of x plus log of log y of y. So just understand that I have just expand out what does it mean by this thing. Okay. So log of AB equal to log A. So let's say base C. So log A plus log B. Okay. Okay. And then so what I had here, we had, so look at this thing, what I have here. So the first thing is equal to 1 plus log I of x. So actually you can do a better thing, I will tell you later. The plus 1 plus so this thing is giving me this. Okay. So then what you are getting 2 plus log yx plus log x y. Now notice what, so if log x of y, this is equal to b, so what does that mean? That means y equal to b to the power x. So that means if you take, so you have to invert it, right? So you have to get the base same. So if you take log y, what do you get? Log y of y, this is equal to, so log y of b to the x, which actually is x log y of, and if you put b, you get log of x y, right? Which is actually, so sorry, just let me do the calculation once and then I'll tell you. So your thing was log x of xy, this was equal to b, and that means xy equal to u. So this is equal to x to the power b. Yeah, I was wrong. So that means y equal to x to the power. So I have to get it to xy, right? So this is x to the power b minus 1 and x to the power b minus 1, and what you get on the other side, log y of xy, this is equal to c. Then what you get from here, similarly, you get x equal to y to the power c minus 1. Then what do you have actually? If you put your y back here, you get x to the power b minus 1 times c minus 1. So that is actually x to the power b c minus c minus b and plus x, that is times x, is equal to this. So x to the power bc minus c plus b equal to 1. So I'm getting this. Okay. Are you there?
So can you explain the last 3 steps again?
So what I get here, so you forget all these things, okay? So you write log x, if you look at the question, go back, p equal to log x of xy, I have write just b, okay? So here b is actually p. So log of xy, log x of xy equal to b, and here it was p. So just let me just rewrite the question. So this is not p, this is b, and this is not q, this is c. Okay, and forget all these things. Forget all these things except the question. You do not forget this, and then you come back here. What is it saying? It's saying that log of x of xy is equal to b. So I've just written it down. What does it mean by log of x? So this is equal. This means xy equal to x to the power b, and that means y equal to x to the power. You just divide by x on both the sides. So you get y equal to x to the power b minus 1. So you do same thing here. You do same thing here. Okay. The same thing here means I mean you do the same thing here. Okay, here. So from this line, what you get, x equal to y to the power c minus 1, just by similar calculation. In between, there will be this line only. There will be this line only, xy equal to y to the power c. So if you divide both the side by c minus by y, you get x equal to c minus 1. So, and now what you get here, y you got here y equal to b to the x to the power b minus 1. You just put back here. Okay, then x to the power b whole to the power c minus 1, which is nothing but x to the power b minus 1 times c minus 1. So, and if you write it down, what you get here, you get this. If you just so let me rewrite it if it is clumsy for you. So this is what you get from here. So from this line to this. Okay. So what you get, x equal to x to the power b minus 1 times c minus 1. So this is x to the power bc minus c minus b plus 1. Is it okay?
But for exponents, shouldn't we add them only, not multiply them? If it's
No.
something to the raised to.
So yeah, okay. So exponent x to the power a whole to the power b, this is equal to x to the power ab. And what you are saying, x to the power a times x to the power b.
AB or AC?
Okay. Does it answer your question? Who asked the question, please, sir? Does it answer your question?
Yes, sir.
Does it answer?
Yes, sir.
Okay, fine. Okay, so let me go back. So now, from this, what I get, I divide both sides by x. Then what I get, x to the power bc minus c plus b. This is equal to 1. So this means bc minus b plus c equal to 0. Because this is equal to x to the power 0. Or in other word, you take log x, log base x. So that will give you this equation. So that means bc equal to b plus c, and your question was to find b plus c is equal to what? So this is b plus c. Okay. Yeah, b plus c equal to bc. Okay. So next question. Is there any other? So let me see the second question. Second question says that a box has. So is it okay for all of you?
Yes, sir.
Okay, thank you. So I think there was some. Okay. So if someone is waiting, please let me know. Okay. Okay. So the next question says a box. So let me write down the question. Question 2. A box has 10 red balls and 5 black balls. A ball is selected from the box if the ball is red, it is returned to the box.
Sir, I can see the writing, sir.
Oh, you cannot see the writing, is it? Now,
Okay, okay.
if the ball is black, it and two additional black balls are added to the box. The probability that a second ball selected from the box will be red is A 47 by 72, B 25 by 72, C. Oh my God, there are only two. Are there only two options? Who sent me the question? Please respond. Please respond. Who sent me the question?
Yes, sir.
There are only two options. Are there only two options?
Sir.
Please.
So the other options are 55 by 153 and 98 by 153.
55 by
53
and
98 by 153.
98 by 150. Please all of you note down the question. Okay. So how should I do this?
So can you show the question for a bit?
You can see. So should I start? Are you finished
Yes,
writing?
sir. Thank you. Yeah, thank you.
Yeah. Okay. So yeah. So it says that so your second ball, the probability. So let A be the event. A be the event. The second ball drawn is red. Correct? So it is fully dependent on what happened in your first draw, right? It could have come out red, it could have come out black.
Sir, can your voice got broke?
Sorry? Sorry, can you repeat again? Who?
Sir, can you please repeat because your voice broke? Couldn't heard actually.
Oh, so what I said that suppose the second ball drawn is red. So it is fully dependent what happened in the first drawn in the first place. So in the first place, suppose the ball was red. So if it was red, it was just put back. If it was black, this ball plus 2 black ball was dropped, was put in the bag. So it fully depends what happened in your first draw, right? So let E1 be the event. E1 be the event. The first drawn ball was red, and E2 with the event, the first drawn ball was black. So then probability of A is actually probability of A. Wait a minute. Probability of A give me a minute. So this is intersection your E1 union E2. So do you understand this? Tell me first. So, and this is a disjoint union. Why is this? Because disjoint union, why? So your whole event comes with two things. Either the first event comes with only two possibilities. The first possibility is it can be your E1, which is the ball was red, or it can be E2, the ball was black. So this is equal to probability of A intersection E1 union probability of E1 union A intersection E2. And this is just the distribution law of intersection over union. So do you understand this?
Sir, can you explain this PA is equals to APA intersection? How is it possible, sir?
Oh, okay.
Again?
Surely. Yeah, surely. So you see, so suppose your whole event, so your event A, I'm saying A, so A equal to your A union, A intersection whole event. Whole event omega is the first wall is drawn. Okay. The first ball is drawn. So the first ball is drawn, it can be either E1 or E2. So this is this. So do you understand this?
Yes, sir. Yes, sir. Understood, sir.
Okay. So A is equal to A intersection your A intersection omega, and from that equality came. Now so you look at this, it says that P of A intersection E1. So I'm talking about this thing. So if you write it down in terms of probability, what do you get? You get this is equal to probability of A1 intersection E1, sorry, not A1, A intersection E1 plus probability of A intersection E2. So now this is equal to probability of A given E1 times probability of E1 plus probability of A given E2 times probability of E2. So this has a fancy name. I don't remember. That's why I didn't write it directly. So I don't know. Does anybody know what is this known as? Someone's name start from B. Bayesian.
Condition.
Law of total probability.
Yeah, conditional probability, something related to conditional probability, and this guy is called the conditional probability of A given E1.
No, sir, I'm saying law of total probability.
Law of total probability, and that was actually named after one of the famous mathematician. I don't remember his name. I'm sorry to you and to that mathematician as well.
Bias.
Bias or Bayesian law, probably.
Bayes rule, Bayes theorem.
Yes, Bayes rule, correct.
Bayes
So,
theorem,
okay,
yes.
so let us not spend time on that. So it says probability of A given E1 times probability of E1 plus probability of A given E2 times probability of E2. So we have to find these respective probabilities, then we have to multiply and add them. I'll find the probability and leave the calculation to you to do. Okay. Is that good? Is that okay? Someone has a question?
Yes, sir. Okay. But someone mic is on.
Okay. So, so what I have to do, I have to find these probabilities. So P of E1, what is P of E1? These are small, easier. So I have to, I can do it easily. So let me go back to the question, and that says that there are 10 red balls and 5 black balls, and E1 is the event of drawing the red ball. So there are 10 red balls and total 15 balls. So it was 10 upon 15, which was actually 2 by 3. So, and P of E2 is equal to 5 by 15, which is 1 upon 3. Now, what is probability of A given E1? So, A given E1 is you draw the red ball and then you put it back just. So just look at the question. What did it say? What did you do? If the ball is red, you just return it to the box or into the bag. So if you return it to the box, it again has 10 red balls and 5 black balls. So getting the black ball again will have the same probability as 5 over 15. So it is 1 upon 3. Yeah.
Sir, but in question it's written that if we get a black ball, we have to put 2 additional black balls in the box.
Yeah. That is I'm coming here. So what is E2? A given E2. So if you get the black ball, so you have to put additional 2 black balls back inside. So now your probability changes. Now so now you have 7 black balls and total 10 plus 7. So 7 by 17. So your total probability P of A will be this 1/3 times P of P2, which is 2 by 3 plus 7 by 17 times 1 upon 3. So you do this calculation, whatever comes out will be the result.
Sir, after this class, can you please send these PDFs in the form of PDF, the notes?
Yeah, sure. I'll send it to Saurabh sir. You will send it to you.
So can you send the PDF of the previous lecture as well? The one which we had on Sunday.
Okay, yeah, I'll try. I'll send both them. Okay.
Thank you, sir.
Okay. So, okay. Now, any other question? By the meantime, anyone has sent any question? So please send if you have other questions. Are you guys, do you have any
Sir,
questions?
sir, I already sent you a geometry question on Sunday.
Sunday, oh, you sent me. Yeah, I didn't look at it. I'll share.
Sir, I have a question. Can I send it to now?
Yeah, sure. I have write down the mobile number. I am sending it again. So you just check the chat box. You can see on your screen as well now. You save this mobile number and send me the message on WhatsApp. Okay. So I've got another. So yeah, so it is, I guess. Okay. So first of all, I would like to request you, please don't send any question related to this statistics and your differential equation and any applied mathematics. Okay. So okay.
Sir,
Yes.
sir, in the previous question of probability only, where you have written PA even, PA by even, that is 5 by 15 or it will be 10 by 15?
Where?
Sir,
by
where you have this 5 by 15? Yes, sir.
So A, what is A? Do you see what is A? Oh, sorry. Yeah, you are correct. You are correct.
Sir, it will be.
Yeah. I saw that it was blackboard done. So it is 10, and so it will be
By
2,
15.
2 by 3, and so it will be 10. Okay. So it will be 10, and so okay. So your things will change.
Sir, that is correct, sir. 5 plus 2 is 7, no? 10 by 17. Okay, sir.
Yeah, 10 by 17. It will be 10 by 17. Okay.
Hmm.
So I'm not doing the
Yes.
addition. Should I do it?
No, sir, it's fine.
Okay, good, great. Okay. So, yeah, any question in the meantime? Yeah, there is a question. Let me write it down. It says that question 3 says that fx be a function of real variable and let delta f be the function delta f of x is equal to fx plus 1 minus f. Now for k greater than 2, for k greater than 1, delta kf equal to, it is defined recursively as this, right? Okay. So you see delta, now you see what is delta 2 of f. So delta 2 of f is delta of delta f, right? So this is equal to delta of f of x plus 1 at x, you say. So delta of fx plus 1 minus delta of x. So this is equal to.
Sir, delta of delta square f?
So I'm saying this is. I'm not written down what are the. I mean, the question says something more. Then find delta kf, and there are some formulas for it. Okay. So and now the solution here. So let me write down the options here as well. So option A is summation j equal to 0 to k minus 1 whole to the power j k plus j f of x plus j. Option B, summation over j equal to 0 to k minus 1 whole to the power j plus 1, k choose j, f of x plus j, and option C, this is minus j equal to 0 to k minus 1 whole to the power j, k choose j times f of x plus k minus j, and option D is summation over j equal to 0 to k minus 1 whole to the power j plus 1, k choose j, f of x plus k minus j. These are the options. This is the total question. Please write it down quickly.
Sir, the third option is fk plus k minus j or xk plus k minus j.
This is x plus.
Okay, that's x. Okay, thank you.
So please inform me if you are finished writing. Finished with your writing. So okay, so let me solve this question. So it is so your delta f, this is given to be f of x, this is f of x plus 1 minus f of x. So delta 2 f of x, this will be delta of delta f of x. So this is actually delta f of x plus 1 minus delta f of so delta f of x. Now this is what? This is delta f of x plus 2 minus delta f of, so why I'm writing, so no, this will not will be delta, this is just f of x. Why I'm writing this? So that is the main thing, why I'm writing this again. So by this, I'll try to predict what will be the answer. Okay, so and you have to use this mathematical induction to prove what will be for the integer k. What will be the answer for the integer k? So this is f of x plus 1 minus f of x. So okay, so this is f of x plus 2 minus f of x plus 1 minus f of x plus 1 plus f of x, so which is basically f of x plus 2 minus f of 2 into f of x plus 1 plus f of x. So you can see this is summation over j runs from 0 to. So let me check if the answer, whatever the options are, which options actually are coherent with respect to this this equation for k equal to 2. So let me go back to the options. So if k equal to 2, the first option actually gives you let me write, suppose k equal to 2, so j equal to 0 means k choose 0, so this is 2, so f of x, then j equal to 1, so k choose 1 means 2 choose 1 minus 2, f of x plus 1 plus k equal to 2, 2 choose minus 1 whole to the power 2 is 2, sorry, is 1, and k choose 2 choose 2 is 1, so this is f of x plus 2. So this actually meets it. So I cannot say this is right or wrong, but I cannot conclude anything. So if you look at B, if you look at option B, is this multi-option correct by any chance?
No, sir.
Okay. So if you look at option B, then So if you put j equal to 0, you get minus f of x, then plus 2 f of x plus 1 minus f of x plus 2. Surely this is not the option. So you get this is wrong. So you get this is wrong. You cannot say whether A is correct or not, but you can definitely say B is wrong. So now let me look at option 3. What option 3 gives you? At j equal to 0, what you get? K choose 0 is 1. So this is x plus k means 2 minus 0. So if of x plus 2 minus j equal to 1 means minus k choose 2 choose 1 means 2 f of x plus 1 minus f of, so not minus, so if you put j equal to 2, you get minus 1 whole square equal to 1, k choose 2, k means 2 here, 2 choose 2 is 1, so plus, if you put j equal to 2 back here, you get f of x. So you cannot conclude whether C is wrong or right, but you can definitely see this is wrong. So you get this f of x plus 2, because if you put j equal to 0, then minus 1 whole to the power 1 is minus 1, k choose 0 is 0, and f of x f of x plus k minus f of x plus 2 minus 0, here f of x plus 2 minus 0 is f of x plus 2. Now then calculate it, you will get f of x here, f of x plus 1 here, minus f of x. So definitely this is not again the option. So you have only two options left to check. So what I will do is I'll calculate delta 3. So let me change my color. So delta 3. So do people understand what I'm trying to do? I'm trying to see what will be, what can be, what might be the answer. Okay. So delta f of x is equal to delta of,
Sir, hello.
yes.
Sir, why option D is incorrect?
See, you see that if we have plus here. What did you have here? What did you have here? You see here we have plus. We have plus here, right? Here the sign is plus, but if you go
Okay.
here the sign is minus. You see?
Oh, okay.
You see that?
Yes, sir.
Okay. So let me calculate this guy delta 2. So this is actually delta of fx plus 2 minus 2 delta of 2f of x plus 1 minus, oh, what I'm doing, sorry. I'm not given that this function is linear, right? So I have to write.
Sir, can you explain the third step, that del square fx equals to del of fx? Then why you wrote del f of x plus 1 after that?
Whatever I erased, I was wrong. That's why I erased. So I'm writing it here again. So this is equal to delta 2f of x plus 1 minus delta 2 of fx.
Sir, it is not seen in the screen.
Yeah, now you see.
Yes, sir.
Okay. So now you have your delta 2. Delta 2 of fx you have calculated here, right? So you put it back there. So what do you get? Delta 2. For delta 2 of f of x, you get f of x plus 1 plus 2 minus 2 into f of x plus 1 plus 1 plus f of x plus 1, and now minus f of x plus 2 minus 2 into f of x plus 1 plus f of x. Do you agree? Do you agree? So this actually gives you f of x minus f of 3 minus 2 into, so this minus and this minus give you plus, oh no, sorry, this minus and this minus, this plus give you minus, so you get 3 times f of x. Divya,
Someone mic is on.
Divya, please mute. Thank you. And this is plus f of x plus 1, and this minus give you plus 3 of f of x plus 1, and lastly what you get? You get plus or minus f. Correct? So you have 2, 1, 2, 3, 4, 5, 6, 7, 8 terms. 1, 3, 4, 7, 8 terms. Yes? So is it okay? Okay. So now let me again go back to that expression. If everything is till now is same as what we have been what we want to see. Okay, so we have to check. So I'm erasing this part. Okay, I'm erasing this part. Now I'll do the calculation for 3. So I'll not do the calculation for all of 3 because I know option B and D are wrong. I have to check option A and option C. Okay. So option A, it says that if you put j equal to k equal to 3, so here my k will be in this whole calculation, k will be 3. K will be 3. Okay. Now let us go back to our calculation. It says now put j equal to 0, you get k choose 0, which is 1, and f of x plus 3 minus. If you put j equal to 1, you get k choose 1, which is 3, and f of x plus 1. So let me check if I am getting everything okay. I'll check later. Oh, I'm wrong here. Sorry. So this is f of x. If you put j equal to 0, minus 1 whole to the, so here minus 1 whole to the power 1 is 1, k choose 0 is 1, and f of x plus 0 is f of x. So here it is the resultant thing. And then what you get, if you put j equal to 2, this becomes minus 1 whole to the power 2, which is plus 1. So this is plus, and k choose, here k choose 2, which k is 3 here, so k choose 2 is 3 again, and f of x plus 2. And then again if you go back, if you take j equal to say what I have done until 2. So if you put j equal to 3, what do you get? It is minus, so it is minus k 3 choose 3 is 1, and minus f of x plus 3. So let me check if this thing is a thing in we got here. So here it is saying that we have a plus sign here, right? But here it is saying we have minus sign here. So definitely A is not correct. So what we have got, A is not correct. So definitely in your mind you can now say that C will be correct, but until you prove it. But in the case of MCQ, you can now say that C is correct, but for the sake of completeness, let me show why C is correct. Do you understand why I have all until now? Do you understand that? What has been done so far? Is there any question?
No, sir, understood.
Okay, thank you. So I'll actually prove that this is the right this is This is the right explanation of f of x plus delta to the power k of f of x. Okay, so let me look at the let me write down the options. What is delta to the k first? So delta to the k is actually delta to the k of f of x. This is actually summation j equal to 0 k minus 1 whole to the power j, k choose j, f of x plus k minus j. Okay, so let me prove it. So now you use induction. So by induction, we use induction. So I have proved the result for k equal to 2, and I assume it is to be true for k. Now I'll show it is true for k plus 1. So delta k plus 1 of f of x, what you get, delta to the power delta k of f of x. So this is actually delta k of f of x plus 1 minus delta k of f of x. Okay, now I'll put the value of delta k here. So what you get, summation over j runs from 0 to k minus 1 whole to the power j, k choose j. Now instead of x, I have to write x plus 1, f of x plus 1 plus k minus j, and then minus summation over j runs from 0 to k minus 1 whole to the power j, k choose j, f of x plus k minus j. So is it okay until this, students?
Yeah.
Okay, very nice. So now I'll have to accommodate somehow all those guys who have same this coefficients, this number. Okay, same argument. Okay, so let me write it down. Just I'll tweak it a bit. I'll tweak the sum. K choose j, f of x plus 1 plus k minus j. It remains the same, but I'll tweak this one. This guy I'm going to write it as minus 1 whole to the power j. So I'm writing it minus plus j plus 1. Okay, and what else? Tell me. And this is going to be f of x plus 1 plus k minus j minus 1. Check if it is okay for you. If anything has been written extra. Has anything been written extra? Please, sir.
No, sir, but can I say something that if j0 summation k, if we take common minus 1 whole to the power j, kj, then f of x plus 1 plus k minus j minus of f of x plus k minus j, that is equal to del of f of x plus k minus j. That proves that del of del k f x.
So it you no. So what you are saying? So you are saying that. So let me write it here. What you are saying? Just repeat it again. It is equal to summation over.
If we take common.
You are taking common this guy.
Yes.
And then k choose j.
Yes.
Then f of x plus f of x plus 1 plus k minus j into f of
minus of
x plus k minus j. So what do you get here? What do you get here? Tell me.
I get here del of
Del f x plus 1 plus
x plus k plus minus j.
So am I up somewhere or am I up to? Is this giving you something?
This is giving me that with instead of f we can write del f.
Right. And this is very nice. Very good. So this is actually delta k of, you are saying this is delta f, right?
Yes.
So let me check if we are running into any cyclic argument. So this is delta k of delta f. So now you want to say this is equal to delta k plus 1 of f of x, right? You want to say this?
Yes.
So let me just check. So let us assume the result for k, then I have to amend the hypothesis. This is true for s being equal to k. So now what you do? This is so this is actually delta k minus 1 of delta 2 of f of x. Now you know the result for, actually you know the result for k, right? So you can directly write. So no, sorry. No, I'm wrong. So what happens here? So you write it this, then you write it this times delta k to the power minus 1 of delta f of x. Aren't we running into the same loop? Aren't we running into the same loop?
Actually, I don't know.
We are running into the same loop. You cannot use cyclic argument. Okay, you cannot use cyclic argument. So just me.
Actually, we use the same that logic that use in fast. So
basically, whatever you are saying is this. So delta k of delta, this is equal to delta of delta k. So this is what you have to prove.
okay.
So basically, not exactly that. So what you have to prove is you have to prove that delta k plus 1 of f, this has that big chunk of expression. Okay, so you have to prove that, not anything else. Your proof is not at all there. You have to prove it.
Okay. Oh, sorry. I understood.
Okay, your proof has been shifted. So let me look at what was the expression. So our expression is this. So let me just copy it on the other side. So it says this is equal to j runs from 0 to k minus 1 whole to the power j. K choose j, f of x plus 1 plus k minus j plus j runs from 0 to k, f of x plus 1 plus k minus j minus 1. So now this is, so now here we have this thing. So now this is, here you have to do a little bit of calculation. So what you do here, you just write minus 1 whole to the power, so minus 1 whole to the power 0 is the largest thing you get. F of x plus 1 plus k, you take it out. Okay, then so what you get here, J runs from 0 to k minus 1, k choose j, f of x plus 1, j returns minus 1 for j, and there also was something minus 1 whole to the power j plus 1, k choose j. Yeah. So this is, what is this? So this is x plus 1 minus plus k minus j, and okay, this is from the second, you get j runs from 0. So this is just basically, so you singled out 0 from here. So what you get, j runs from again 0 to, here I have done a mistake, you should be smart enough to point it out. So I put 0, I put j equal to 0 and take this term out, so it will be j runs from 1 to k. Now I'll put j equal to k, I'll put j equal to k, so I'll get up to k plus 1. Here it is minus 1 whole to the power, what was this, j. So this is minus 1 whole to the power j plus 1, k choose j, and f of x plus 1 plus k minus j minus 1, and I have to write k, right? So what do you get here? Minus 1 all to the k, f of k choose k is 1, so you get f of x plus 1, you put k here, plus k minus plus 1. So all this day I have been writing it plus or minus 1. So I said again, you should be careful. Here it will be plus 1, not minus. So because see, if you don't subtract it here, you have written this plus 1 extra. So you have to take it out. So I am taking it out. So this guy will be plus 1 again. Okay. So this is minus 1. So this out. So what actually I get, f of x plus 1 plus k plus, what is this? Tell me, f of x, not only f of x, minus 1 whole to the power k, f of, so am I writing it okay? No, it was k plus 1. You put k plus 1 here, k here, so it was j plus 1, so it will be k plus 1. So I have to see these two terms. What do I get from these two terms, right? Do you see? Hello?
Yes, sir.
Yeah, is it okay? So
J,
let me
sir.
copy. Yeah.
Sir, j is equal to 0 to k minus 1. Can you please repeat that?
Yeah, sure. So okay. So here it was j equal to 0 to k, all this thing up to this. So what I did, I didn't write this k term. So j equal to 0 to k minus 1 whole to the power j plus 1. I kept it as it is. Now I put j equal to k. Sorry, j equal to k. So if you put j equal to k here, you get minus 1 whole to the power k. K choose k is 1, and f of x plus 1 plus k minus k plus 1. So minus k minus 1. So these things get cancelled, and you get this.
Okay.
Okay, and I didn't write this sum here. I'll write it in a minute. First, let me calculate these two. Okay.
Okay.
Oh, nice. So let me write it down on the other side first, then I will show you. So have to be careful very. Minus 1 whole to the j, k choose j, f of x plus 1 plus k minus j, plus minus j equal to 0 to k minus 1, minus 1 whole to the power j plus 1, k choose j, f of x plus 1 plus k minus j plus 1. So this is what I have. Okay. So this, so what you do, you rename this sum. You put j equal to j plus 1. So here you what you get, then if you put j equal to j plus 1, you this guy becomes j equal to 1 to k j to j equal to j minus k minus 1 it was, so it will be k minus 1 plus 1, so it will be k, and you put this is the j, you have put j equal to j plus 1, so it will be j, and you have put j equal to j plus 1, so j will become j minus 1, right? J minus 1. You have put j equal to j plus 1. Surely. So this is what I get, and this is j plus 1 you get. Okay. So now, so is this okay? Are you with me till now? Till now, are you with me? Yeah. Okay. So whole to the power j. This is up to k. So now you see that this is common, this is common, this is common, this is common, this guy is common, this guy is common. So you take all those things out. X plus 1 plus k minus j, and now you have k choose j, k choose j minus 1, which is actually what you wanted. K minus j, f of x plus k plus 1, k minus j. So bracket closed, it is k plus 1 choose j. This guy, this is the identity I am using. So the identity I am using is this. So k choose j plus k of j, k choose j minus 1, k plus 1 choose j. Okay. So if you put it here, if you put whatever you have got there back in the equation, you have minus 1 whole to the power j, f of x plus 1 plus k minus j, k plus 1 choose j. So this is what you are getting. Now if you club all these things together, what do you get here? So let me write it here. So see, if you so this sum is actually, just convince yourself. I'll help you here. K plus 1 choose j, f of x plus k plus 1 minus j. So see, if you put j equal to 0 here in this equation, put j equal to 0 here. So what you get here? What you get here? Then if you put 0, then minus 1 whole to the power 0 here. So this is plus 1 here, and k plus 1 choose this. Let me write it clearly. So k plus 1 choose j, which is 0. K plus 1 choose 0, which is 1. So it is 1 here, and you put j equal to 0. So you get this term. Clear? Hello?
Yes, sir. Yes, sir. If we put j is equal to 0, then we get f of x plus 1 plus k.
And now if you put k plus 1, so you get,
And we get minus 1 whole to the power k plus 1 fx.
so you get here, and the rest of the term is here. So, and this was your expression. Okay.
Okay, sir.
Yeah. So this was your expression. You check. Let me go back to the problem. Let me go back to the problem. Yes. It should have been j equal to 0 to k plus 1 minus 1 whole to the power j, and then k plus 1 choose j, sorry, where I'm writing. So minus 1, j runs from 0 to k plus 1, minus 1 whole to the power j, k plus 1 choose j, f of x plus, here it will be k plus 1 minus j. So you see on the penultimate page, you get the same thing. Okay?
Okay. If it is MCQ, then it is very okay. If it will be.
No. It
But-
was MCQ. That's why within just, if you check just 3 and you are done.
Yeah.
And
But if it will be in 10 marks, then I have to prove.
write all these steps.
Yes.
Okay.
Okay,
So
sir.
nice to interacting. It was nice feeling to interact with you. So let
Sir,
me.
can you do that last question?
What question?
Sir, the
No,
last question.
actually, I am in office. I have to go back to home. It's night. It's 10:12. You see here. It's 10:12, and my office is going to close now. I have to. My permission was 10 up to 10 p.m. and it is already 10:12. Security is about to come. Okay, we'll meet again.
Sir, which
soon.
office, sir?
Sorry?
Sir, which
Sorry?
office you sit?
Yeah, I work in an office, so in that office. I'm not supposed to tell about my personal things here. It is all about to you.
Okay, sir, no.
To Excel, and it's all about Saurabh sir classes. Nothing personal from my side. Okay. Good night, guys.
Good night, sir.
Okay, thank you, sir. Good night.